Okay. They used alpha particles to generate neutrons, which they then used to see whether they could fission or transmute other things. And they finally got to uranium. And when they did, something else magical happened. Not only did it transmute your uranium into, barium and krypton, basically, and some other fission things, but it released in every transmutation enough neutrons to keep the reaction going. This had never happened before. And when this occurred, people immediately thought about the possibility of creating a nuclear bomb. Because each time you do these transmutations, you're going to a more stable state, and there's a certain amount of energy that's released. If you can keep that going long enough, you can get a massive release of energy. Okay. Now you can do this reaction slowly, and you can produce heat for boiling water to make electricity as well. So there's sort of a fast and a slow version of this. But that would require moderating the speed and the amount of neutrons that are absorbed so that you could, quote unquote, control the reaction. All right, let's go to the next slide. Okay, now you've all been itching to understand E equals mc squared all of your life, I suspect. I'm not sure in the end it's understandable, but we can shed more light on this than probably was there before. As I mentioned, most folks up until the 20th century thought that you could only have chemical exchanges, and therefore the amount of energy in any system could only be converted to an equal amount of energy in another system. So that, you would burn coal and have a certain amount of energy, and you could convert it into steam, which could then convert it to electrical power if you had a turbine. But that what you put in is what you got out, and you could measure that, and it would always equal. This is sort of like a Newtonian understanding of things. At no time did anyone believe that energy could come from mass, or mass could come from energy. Those things were considered given. What Einstein figured out is not only that mass could be converted into energy, but actually what the formula was for that. And it is essentially this formula, which has changed an awful lot of our lives. If you take the mass of some sort and you multiply it times the speed of light squared, you get a very big number. Why? Because you're talking about 3 to the 10th power of centimeters when you're talking about the speed of light. That 10th power means the number of zeros behind it, okay? So that's a lot of zeros. And if you square that, well, you get 20 zeros. Then whatever the mass is that you've given up, remember that binding energy? Where the binding energy of separate things is less than the binding energy of things that are bound together. And that binding curve, when you do transmutations and elements have different amounts of binding energy, and if you fission one element so that it goes to something more stable on that curve, you have a release of energy. Well, what you're measuring more than anything else to try to figure out how much energy is released is, well, how much mass is given up to get that binding measure, binding energy. So let's go to the next slide and see whether we can do a little bit of math. Okay, now we're interested in nuclear weapons, aren't we? I think that's part of what this course is about. Generally, in a bomb, a nominal bomb like the Hiroshima and the Nagasaki weapon, they call them nominal. They're around 10 to 20 kiloton yield weapons. These things essentially are trying to fission 1 kilogram, that's 2.2 pounds of the fissile material, plutonium or uranium, the isotope being U-235, and we'll get to that in a moment. The amount of material that is after it's fissioned in barium fractions and krypton pretty much equals the same amount, less 1 gram. So essentially, you're obliterating 1 gram of mass, and that mass is being converted into energy. It's just 1 gram. So let's take a look at what 1 gram on EMC squared turns out to be. Now, it's 1 gram times the speed of light. Then you use a constant, which is 4.2 times 10 to the 7. You end up with a number that is E equals the energy released by getting rid of that 1 gram by the fissioning of 2.1 10 to the 13th calories. Now, I did a rough calculation. I believe that's 20 quadrillion calories. Anyone thinking of going on a diet? That would be really difficult to overcome. I mean, that's like a lot of jogging, you know? That is the revolution that we were talking about, that you could get that kind of release with the fissioning of 1 kilogram and the elimination of 1 gram of matter.